Well, first of all, thank you all for being here, and thanks to the committee for this opportunity. So, first of all, a forewarning, two important premises. This work is extremely preliminary, so any input is more than welcome. And secondly, there's no script, but the slides content will generally match what I say. So for accessibility, you can just follow what's written. Now, what is the context for this analysis? As we know, in the grim darkness of the far future, there is only war. So this is going to focus eminently on the military aspect of economics. We are going to overlook some civilian aspects of it. So the imperial nobles, sorry, they're not getting any love today. Furthermore, we must acknowledge that every faction in the Warhammer 40,000 universe approaches this challenge in a very different way, so much so that we can actually put them on a sort of ethos axis, if you will. And we can see that many operate in some sort of collectivism, many times a command economy collectivism, such as the Imperium of Men. And on the other opposite end of the spectrum, we have anarcho-capitalism, so people that appropriate resources regardless of who they belong to. Even there are some factions. There are, to my knowledge, two very important exceptions to this. One is the Leagues of Otan, which seem to be practicing some form of capitalism, which we don't at this item know much about. And secondly, we have the Leptus Mechanicus, which actually practice theoretically collectivism, but in fact have a large influence of individual capitalism, because each and every makers will try to accrue as many augmentations and knowledge as possible only for themselves. They operate only from an individual perspective in that regard, but see notable exceptions such as Belisaris Call. So, why does this matter? Because again, in the grim darkness of the far future, there is only war, and war requires resources. So these resources have to be somehow distributed, produced, and actually used. And we know that the galaxy, especially in the setting, in its current state, is an extremely fractured supply network. So we can presume that into three different frameworks, according to the closeness to the deciding agent. One is classical economics, which are the ones that we already know, and they concern all resources that you can get your hands on or already know about. Then we have relativistic economics, that are resources located far enough that you need a spaceship traveling close to the speed of light to get them, but not far enough to justify possible night travel, especially with the challenges this might entail. And then we have post-relativistic economics for resources anywhere else. So let's talk about relativistic economics. We have introduced a concept from general relativity, which is light currents. And it's basically every possible path that a photon can take from a specific point. And for its representation, this is a 2D slide. So let's take a one-dimensional space, like a string or a piece of rope, and let's add time. And conveniently, let us introduce a scale factor of the speed of light for the time axis. And again, we have shrunk the time axis by the speed of light. Now, this is called a Minkowski space diagram, and anything that is in red region is faster than light, because these lines that you see are at 45-degree angles. So anything above is traveling slower than the speed of light, anything in the red faster. Now, the time and energy that we actually have to spend to get a certain resource will be our definition of closeness. And first, we encountered the classical economic sphere we mentioned before, and now we are in the relativistic region. But there is one important observation we have to make about this region. A central finding of general relativity is that events are not simultaneous in absolute sense. They are only absolute with respect to a given frame of observation, and so a given person or entity observing them. Now, this is actually due to a precise phenomenon that was discovered before relativity, as a matter of fact, that length of time and space will actually contract or extend, according to whether we're talking about space or time, according to the speed of the frame of observation. So, a standing observer will have a very different perception of reality from a moving one. And this means, actually, that this is employed in settings, namely in Gene Father, which propose to take advantage of this relativistic effect to actually visit a region of the universe that is still in the time of the war in heaven. Now, how can this actually influence our decision makers? Well, due to this, commanders can actually peer into the future, because if you were to actually have some convenient observing point that is moving, then you glimpse some days ahead, of what you are seeing if you stand still. And so these might be extremely convenient, for instance, to see the outcome of an engagement in another galactic sector, whether the reinforcements you requested actually departed, or whether you should say your last prayer to the Emperor. Now, as we said, this is the Minkowski space dynamic diagram, and it's going to help us explore the means of distribution for these resources. Because we know that on top of relativistic travel, we also have faster than light travel in Warhammer 40K. And all species have a mean of faster than light travel, but some have to struggle much more than the other. The Imperium has to take a shortcut through hell, which is pretty daunting. So this will actually enable to go in the previously red zones that were completely inaccessible, minus a little spoiler from a few slides forward, but will enable them to reach more or less all of the diagram we see here. But given that these, as we said, might have a high cost or risk, the risk appetite of the deciding agent will actually decide when they are going to use relativity, or relativistic means at least, and whether they are going to actually do faster than light travel. So let's introduce post-relativistic economics as well. So again, as we mentioned, red zone, beyond the speed of light, and so beyond certain causality, with one notable exception, as we mentioned. This was first discovered by Stockholm and Gödel, but closed time-like curves are perfectly valid solutions to the equations of general relativity. And in these kind of situations, the effects and the causes actually become one and the same. Now, Ulrich and the diviner would be super stoked about this. We actually have another example, several other examples of this happening in the setting, and one is perfectly revealed at the end of the death at the end in volume 3. So, we also have several references of whether to faster than light travel being employed, knowingly or not, to return to the past. For instance, Gritgut, when he finds himself confronting himself, it, of course, makes a very orky decision about having finally a second set of his favorite gun. But again, he did not intend to travel to the past, but he found himself there. This, however, we can presume is actually due to the amount of warp permeation of real space. This is clearly stated several times in Death in the End across all 3 volumes, because the greater the warp presence, the least stringent the bindings of causality become. This is actually a quote from a fantastic passage in the book. And as you can see, it talks about everything and everywhere being accessible with this level of warp permeation that the Horus heresy has at its peak. So, how can a rational or at least coherent decision be taken when causality is not certain? Well, let's go with probabilistic causality. So the above references and more have attested, again, the effect of warp permeation, so much so that we could actually quantify it. We could say the more unlikely events occur, the greater warp permeation must be for this to actually happen. So how does this actually affect classical economic constructs? Again, please note that we are talking about economics in general and not currency. There's a fantastic result by Aguiar and Hurst in 2010 that shows that expenditure is a thing, but consumption is a whole other game, and consumption tends to be much more reliable and predictable than expenditure. So, this is Euler's equation for consumption in the neoclassical model. Don't worry, it seems daunting, but it's actually pretty approachable. However, we also can show, unfortunately, that it's completely invalid in the Warhammer 40,000 settings. This is due to the postulates upon which this equation is derived from. First is the hypothesis that you are going to maximize your utility. You want the best outcome for you, and then, okay, it can hold. But there's a second one, this definition of the utility function. And this is a big problem because we have this little beta over there, and this actually represents a ratio between how you value the present and the past for your consumption. So whether you'd rather shoot your ammunition today or tomorrow. Now, an Imperium general, again, is conducting a very long siege, shooting today, tomorrow, 10,000 shells per second. They're not going to make any difference when they're shot. However, imagine you are an Imperial guardsman with a cannon effects raging at you. your beta will be very close to zero. You have to empty the magazine now because you're going to meet the emperor, so you might as well do it with a clear conscience and no ammunition left. So this as a huge issue. If wall permeation decreases the likelihood of causality holding, then beta is effectively a random parameter because you don't know your future. Causality has become weak. So knowing beta is uncertain, it would be absolutely irrational to use this to make decisions. So one way to tackle this is by using Markov chains. Now, let's make a practical example because the Imperium is, of course, the prime example for this. Should I relocate men from another planet? Please put yourselves in the shoes of a commissar. So thinking lives being absolutely currency, not of any ethical value at all. First, we have to establish the possible events probabilities. So maybe a saint of the emperor will perform a miracle, and that will spare us the effort of 1,000 guardsmen. Who knows? But there's a 1% chance that actually war leaders will attack the planet, and you'd need 1 billion guardsmen to actually hold them at bay. Now, given this estimation of probabilities, this gives us the expected utility of a given war front. Now, if we also perform this for our opponents, we actually get the minimum amount of resources required to probably overcome the foe. For instance, if I know that my utility was 10,000, due to these events, it's going to be only 300, then I know that I have to procure the utility to actually overcome the Necrons attacking me and overcome their expected utility. Now, of course, this is also somehow practiced, of course, not with these formalities, but in the same spirit, by the custodians, which have the doom scryers spitting out prophecies all the time, and sometimes they dignify themselves to actually act upon them and tackle the threats to the Golden Throne that might be divine from them. Of course, realistic cases will be much more complex, especially with interdependent probabilities. So this relies on proxies. What about when you have absolutely none? Well, we can make an assumption that something must happen to deplete or restore our resources. Unless I pull the trigger, the bullet is not going to vanish. More formally, we can expect that the value of utility will remain the same, or rather, the current value is expected to be the next value. And this is precisely the mathematical definition of martingale, which is a super useful probability theory tool to study stochastic processes. Unfortunately, it has some pretty dark implications from a behavioral standpoint for our decision makers. There's a thing called the Dupes optional sampling theorem, or also called the optional stopping theorem, that says stopping a conflict is not expected to produce any value. So if stopping war produces no value whatsoever, why should it? At all, for intents and purposes, it makes diplomacy absolutely worthless, because war is not expected by stopping to produce any utility. So this effectively rationally justifies the state of perpetual war with all factions present in the galaxy. And the martingale actually comes from a betting system. Every time you lose, you double your stakes, so that you try to recoup your losses. And we can see this in the fanatical mindset that very factions bring to the setting. But how often does this lead to the utter depletion of all resources? It's a betting system, so if you want, you can take back. When, not if, you will encounter catastrophic loss. This is also named Gambler's Ruin, and Coolidge made a very elegant statement of it in 1909. A persistent gambler who raises his bet to a fixed fraction of the gambler's bankroll after a win, but does not reduce it after a loss, will eventually and inevitably go broke, even if each bet has a positive expected value. So even if you are expected to win every engagement, to always make constant wins, such as the Emperor of Mankind, still you will inevitably eventually go broke. And this is, of course, again, in the same spirit, but not with the same formalism, referred to in the lore as well. And in that future, the old foe will come to the light, for the quick death and sudden endless stroke for here and where the night will be drawn out forever instead, across the infinite architecture of the galaxy in one eternal act of worship to the powers they represent. To summarize, while each faction has its own economic system, they all share the same constraints. Those constraints are compounded, not simplified, by the availability of faster than light travel, And going beyond causality makes warfare a stochastic process, which are perfectly coherent and give mathematical foundation to the mindset of the Warhammer 40,000 decision makers. Thank you.